Okay, this is the first videos we are going to use to review our exam material. We did that before spring break. Chapter 3.1, we did graphing linear inequalities. Some of them come as a system, so very important. In the past we only do the linear functions like that, so when we did the linear function we did it on a number line and we do interval notation. So this time we will do it on a two-dimensional graph. First we will try to graph the line first by setting the inequality equal to 0, and then we want to graph each of the line. After that, we need to decide if it's a solid line or a dashed line. If it come with the equal sign, that is going to be a solid line. If it doesn't come with equal, then it's going to be a dash or dotted line. After that, we need to decide which part to shade as part of my answer. To do that, most of the time we will test the points. 0, 0 is usually the easiest point to plug in. If 0, 0 is actually on the line, then we will pick another point that is not on the line to test if the statement come as true or false. If true, it means that point is part of the answer. If false, it means that point is not part of the answer. So the shaded part or the overlap the shaded part is going to be part of your answer. If the shaded region have like an enclosed area like that, we call that bounded. If it's not closed like that, it's like going forever one side, it's going to be not bounded. If you look at your notes from the class, we did that, and we started with just graphing a vertical line with x equal to a number, horizontal line with y equal to a number, and the first one doesn't come with equal sign, so it's a dashed line. The second one comes with an equal sign, so it's going to be a solid line. And after that, we plug in 0, 0 to test this inequality. The first one comes with true, meaning 0, 0 is part of the shaded region, so we shaded all of this. And the second one, 0, 0 is also part of the true statement, so we shaded that region. So that's how you do the basic one. And then after that, we did some is not a vertical or horizontal line, such as this one. Number 3 is a dash line. We test 0, 0. 0, 0 is a false statement, so we shade the region that does not include 0, 0. And the next one, we have a solid line with equal. We couldn't test 0, 0 because 0, 0 is part of the line, so we pick another point somewhere that's easy to plug in, and which we end up with a true statement, so this point is part of the answer. All right, and for 5 and 6, we have more than one inequality, so it's a system, so we need to do each individual part, and we shaded this part and this part, so the overlapping shaded part is my final answer. And for this particular one is not bounded because it go on forever over here, right? And number 6 is getting closer to an actual application type of problem, because most of those problem for the x and y value would be greater than 0, meaning in the first quarter, right? I'm sorry, first quadrant, not quarter. So here, so we did the first line, which is testing 0, 0 is part of the solutions for x plus y equal to 6. Okay, so this guy, and then the second one is this one also. 0, 0 is part of the answer, and we need to make sure like it's x and y greater than 0, so this is the overlapping shaded parts, that's my answer. And for this particular one is a bounded shaded area, so that's your answer for that. The very last two questions, actually if you have your notes, please take it up, because I think I shaded like kind of extra part here. So the final answer should be bounded by like x greater than 0 and here and here. So you may have to correct this for me a little bit. I think I did this little extra part here. So again, we did the same process, and this particular one is a not bounded area. So, and this particular corner is not part of the answer. Sorry about that. The very last question, we did a word problem. So this particular one, we actually has to set up the system of inequality and then go through all the steps we just did with graphing it and shading it, and then we found out this is the overlapping shaded area. So this is very useful when we try to make a business decision to see which part is called feasible region, which is the answer highlighted area. So if you pick a point that is within those region is feasible to do those number. If you pick like some combination of number, it would be outside of the region, is not a feasible business decision. So that has a good business application for this. And if you have questions, please let me know. Thank you.